Pre-Calculus 4.5 Day 1. We're going to look at the graphs of sine and cosine. And so we have some ordered pairs here that we want you to plot for your warm-up. I'll get you started on sine. And so when theta is 0, the sine is 0. And when theta is pi 6, and on this is pi 6, this is your pi fourths, and then 2 sets of 30 is 60, so this is your pi thirds. So basically, the pi 6 and the pi thirds divides that 90 degrees into 3 equal parts. And then pi fourths is right in between pi 6 and pi thirds. And so when you go past pi halves, this is your 2 pi thirds. This is 3 pi fourths. And then we have our 5 pi 6. So those same radian angles that we are using on the unit circle. All right, so when sine of 0, when the angle is 0, sine of 0 is 0. When theta is pi 6, the value of sine is 1/2. And when sine is pi fourths, the angle is pi fourths, the value of the sine of pi fourths is 0.7. So kind of eyeball 0.7. And then at pi thirds, it's 0.8. It's about 0.87. So it's starting to get closer to 9. And at pi halves, it's up at 1. So keep on plotting those points through to 2 pi. Okay, so did you get all of those values for sine plotted? We have at pi halves, you're up at 1. And then instead of plotting all the points, we went at pi is 0. 3 pi halves is -1. And 2 pi, this is supposed to be at 0. And then cosine is going to be back at 1. We just got them both in the same spot. And so at 2 pi, you're back at 0. All right, so these values, the sine graph looks like this. And then those points are reflected, so we come down kind of in the reverse order of how we went up. If I were graphing at the 7 pi 6, we'd be at -1/2, then -0.7, then -0.86. So those values are just starting to repeat. And -0.86, -0.7, -1/2, 0. We didn't have all those in the chart, but sine continues. Its domain is the set of all reals. Its range is -1 to 1. So the largest it comes out to be is 1, and the smallest it comes out to be is -1, and that's the range. So there's sine. Sine starts at 0, 0. So then plot the points for cosine. Take a moment, maybe pause and plot those. All right, let's see what you did. Up at 1, and then it's really that point 87866. So almost up at 9, and then the 0.7, then the 0.5, then 0. And that pi, we're at -1. 3 pi halves are at 0. And at 2 pi, we are back up at 1. Now, it's important that these are curved. Some people like to do this kind of thing and connect them, and they almost look like an absolute value. No, you won't get credit for that. These are curves, so you need to show that in your graph. So here's your cosine. It's concave up in between pi halves and 3 pi halves, and then it changes to concave down in this last quadrant. And again, cosine continues. So its domain is all reals, and its range is also -1 to 1. And so you're going to want to memorize those parent functions for sine and cosine and know those values. And some things we're going to be doing this, we can make the graphs taller or shorter by changing the amplitude. We can also multiply by a negative value, which will reflect it over the x-axis. And if we shrink this graph in towards the y-axis or stretch it away from the y-axis, we are making it narrower or wider, and that means we're working and changing what we call the period. The period is going to be 2 pi for just the basic graph of sine and cosine. But then we can change the period, because from 0 to 2 pi, you get all possible outputs, and then the pattern just continues. It repeats itself. And so the period is the length of x values for which you get the entire picture before it starts repeating again. And so we can also move these left and right and up and down, and we'll look at that in our next lesson. So the basic parent graphs, we're going to be using x and sine of x. And what we mean by use the values at these angles, if I just look at plotting the points for 0 pi halves, pi, 3 pi halves, and 2 pi, if I think about the unit circle, and I think about the points on this, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Remember that the sine is the y-coordinate. So if I think at 0, the sign is 0. At pi halves, the sign is 1. At pi, the sign is back at 0. And at 3 pi halves, sign is negative 1. And then we're at 2 pi, we're back to 0. I can get those values in the chart by looking at those quadrantal angles or axial angles, depending on what you're looking at. But the sign of 0 is the y-coordinate at 0. Sign of pi halves is the y-coordinate at pi halves. And sine is back to 0 at pi. It's at negative 1 at 3 pi halves and back up to 0. Those points, 0 for the height, up at 1, then to 0, down to negative 1, and back to 0. Those are the 5 key points that we're going to focus on graphing for sine. Then we can do a similar thing for cosine. So for cosine, 0, again, pi halves, pi, 3 pi halves, and 2 pi. But for cosine, we are looking at the x-coordinates. So we've got at 0, cosine is 1. At pi halves, cosine is 0. At pi, cosine is negative 1. At 3 pi halves, cosine is 0. And if we go a full rotation to 2 pi, cosine again is 1. So these values are going to be 1, 0, negative 1, 0, and then back at 1. And so those are those. At 0, we're up at 1. At pi halves, we're at 0. At pi, we're at negative 1. 3 pi halves are at 0. And at 2 pi, we're back up at 1. And so those are the, just some quick ways to get those points by looking at that unit circle. All right, so we have the standard form. Y equals a sine bx and y equals a cosine bx. The a value affects the amplitude, and if it's negative, we reflect in the x-axis. The b value affects the period. And so in b, we're going to find out that the period is equal to 2 pi divided by b. Or if I switch that out, solve for b, b is 2 pi divided by the period. We're going to be using both of those. And by the way, this is supposed to be pi, so it's supposed to be 2 pi divided by b. It just got substituted, and this is supposed to be 2 pi. Didn't catch those changes when we saved it to a PDF. Sorry about that. All right, and so some of the problems will be as simple as finding the period and the amplitude. And so on A, the amplitude is the absolute value of A, and this A is 3. So the amplitude is just 3. And the period is 2 pi divided by B, and B is 2. So the period of this is pi. So the amplitude is 3 and the period is pi. In part B, the amplitude is 1/4 because 1/4 is already positive. You need to remember that the amplitude is the absolute value of A. It's always positive. And the period, well, we need to think about this as 1/4 cosine of 1/6 x. So the value of B is 1/6. So the period is 2 pi, the normal period of cosine, divided by the value of B. And if you divide by 1/6, you multiply by 6, and you get 12 pi. So the amplitude's 1/4, and the period's 12 pi. In part C, amplitude is always positive, so it needs to be the absolute value of -5, and the amplitude's 5. And the period on this whole coefficient of x is B. So B in this case is 2 pi. And so the period is 2 pi divided by B, but B is 2 pi, and the period on this is 1. So we have the amplitude of 5 and the period of 1. And so example 2, describe the relationships between the graphs of f and g. Consider amplitude and then period, and that's it. And so on this one, in part A, B on both of these is 1. It's a 1x. So their periods are the same. So their periods are the same. So they have the same period, but the amplitude on f is 1, while the amplitude on g of x is 2. So the graph of g, the amplitude is twice that of f. Periods are the same. Okay, in part B, we have cosine of x and a -2 cosine of x. Well, again, B in both of these is 1, so there's no change in period. The period on both of these is 2 pi. But in G, when we have a -2, that means the graph of G is a reflection in the x-axis of f, and the amplitude is twice that. So graph of G, amplitude is twice. Amplitude is twice that of f, and G is a reflection in the x-axis. And periods are the same. All right, so I hope, these, the next pages got kind of mixed up when it changed to a PDF. But example 3 is graph, and we want it over 2 periods. And this line is supposed to be right here. And so when you're doing 3 sine of 2x, the parent function, remember, think on the unit circle, the y-coordinate at 0, 0. Sine starts at 0. And then the 5 key points are pi halves, pi, 3 pi halves, and then 2 pi. And so it goes between 1 and -1. So the parent function, y equals sine of x. We go from 0 at pi halves, we're up at 1. Then we go down to pi, and then we're at -1. And then at 2 pi, we're back at 0. So sketching the parent function. That's just one period, 0 to 2 pi. And so now when we go to graph this, since it's y is equal to 3 sine of x, the amplitude is 3. And then we need to figure out the period. And the period is 2 pi divided by b, and b in this case is 2. So the period is pi. And then we need what we call the key increment. And that is always 1/4 of the period. And so 1/4 of pi, that key increment is pi-fourths. Meaning in the parent function, the key increment here is going by pi halves. So we're going to hit the zeros, the 1, the 0, the -1, and the 0 as we go by the, excuse me, the key increment. And so on this one, the key increment is pi-fourths. What we're going to want to do is grid this up. Pi-fourths, then 2 pi-fourths is a pi-halves, and then we have 3 sets of pi-fourths. And then we have 4 sets of pi-fourths, which is our entire period. And since this is sine, we start at 0. But now we have this vertical stretch of 3. So instead of going up to 1, we're going to go all the way up to 3, and eventually we'll be going all the way down to -3. And we will be up at 3 at pi-fourths instead of at 1. We're at 3 because of that vertical stretch. At pi-halves, we'll be at 0. 3 pi-halves will be at -3, and then at pi, we'll be back at 0. So the key increments were changed because the period is half of what it used to be. And we want to look at marking our graphs by going by the key increments. But this asked you to graph for 2 periods. So what we do is we keep on going by the key increments. So after pi, we'd have a 5 pi-fourths, and a 6 pi-fourths is 3 pi-halves, then a 7 pi-fourths, and then an 8 pi-fourths, which is the same as 2 pi. And then we continue in the same pattern. So at pi, we're at 0. 5 pi-fourths will be at 0. 3 pi-halves will be at, 5 pi-fourths will be up at 3. 3 pi-halves will be at 0. 7 pi-fourths at -3. And then back to 2 pi. So the sine then, make it curved. It's concave down. Changes to concave up at pi-halves. So it's going to be scooped up. Do not make it look like it's pointy like an absolute value graph. This needs to be curved. And then just keep on graphing this. And then concave up. And for 2 periods, we are right there. And of course, it's going to keep on going, but we just wanted it for 2 periods. So there it is for 2 periods. All right, the next one is the cosine, and this is just supposed to be parentheses, cosine of x halves. And so for the cosine of x halves, the amplitude on this is just 1. So it's just going to be going from -1 to 1. But the period, we need to think of this as the cosine of 1/2 x. So that b is 1/2. And you find the period by taking 2 pi divided by b. And if you take 2 pi and divide by 1/2, you end up multiplying by 2. And so the period is 4 pi. And so then we have the key increment, which is 1/4 of your period. And so my key increment is pi. Now, before I get to graphing this, I'm going to go ahead over here and draw the parent function of cosine of x. And remember that cosine starts at 1 because on that unit circle, Okay, so on that unit circle, this first point is 1, 0, and the x value of that is the cosine of 0 degrees. And so the cosine of 0 is 1. And so we start up at 1, and then we go by pi halves on the basic function. You're going to want to be able to sketch that very quickly. So we're going from 1, and we eventually will be down at -1, 1 to 0 to -1 to 0, back up to 1. And there is that parent function of cosine. And now we're not going to have an amplitude change here, but we will have a period change. And the period is 4 pi. So instead of getting one graph at 2 pi, we're going to be all the way at 4 pi before we get this picture. So we have a stretch of this graph. And so we're going to label the x-axis by the period. So we have pi, then by the key increments, 2 pi, 3 pi, 4 pi, then 5 pi, 6 pi, 7 pi, and then we will end at 8 pi because we're going through 2 periods. One period is 4 pi, and 2 periods is 8 pi. And since the amplitude is 1, I'm going to just use two of these as one unit just so that it's not quite so close to the x-axis. And the cosine function is 1 at 0. It's 0, then at the next key increment, -1 at the next, back to 0, and back to 1. So that cosine graph is going to look like this for one period. Cosine of 1/2 x, the period's 4 pi. So we get one picture of cosine in a length of 4 pi. But then they want us to continue and graph it for 2 periods. So we're going to continue. And graph it for 2 periods. So it's important that you do these without using Desmos, and that you identify the period, the key increment, and that you're analyzing the graph to graph it. All right, so in part C, this is supposed to be y equals a -2 sine of pi x. And so there's a reflection in the x-axis, which you just need to remember. And then the amplitude is +2, and the period is 2 pi divided by b, in this case, is pi. It's that coefficient of x. And so the period in this case doesn't have pi in it. It is just an integer value of 2. So that my key increment, ki for key increment, is 1/4 of the period, and 2/4 simplifies to 1/2. So I'm going to be going by 1/2, then 1, then 3/2, then it'll be 2, 5/2, then it'll be 3, 7/2, and then it will be 4. So 0 to 2 for x will get me a full period, and then 2 to 4 will get me a repeat of that period. And now sine's going to start at 0 when there's no phase shift. We're not doing any of those today. But now we're going to go to -2. And since there's a reflection in the x-axis, instead of going up to start, we're going to go down to start. So at 1/2 we'll be at -2, at 1 we'll be at 0, at 3/2 we'll be at +1, and then at 2 we'll be back at 0. So instead of going up to start, it's going to go down because of that reflection in the x-axis. And there is the graph of one period, but they want another period, so continue with that pattern. We're going to go down to -2, back to 0, up to +2, and back down. And there is your graph of sine, -2 sine pi x. Again, you need to not be using Desmos. You need to analyze this and be able to graph these using the key increments. No graphing utility needed. All right, so then you're going to be given graphs and asked to find what the equation is. And so that's what these last three are. And so that's why you want to do when you're graphing these, you need to analyze them to know how to get to the graph so that now we have the graph, we can work in reverse. And in part A, you're supposed to circle if it's sine or cosine. And since it starts at 0, 0, there's no phase shift in this, no movement up or down. We're not doing this. So since there's no phase shift, no moving up or down, when the graph starts at 0, it's got to be a sine graph because the sine of 0 is 0. And then the amplitude, notice it goes from 0 up to 3 and then down to -3. The amplitude is 3. And you get through that going from 0 up to 3 to 0 down to -3 back to 0. You get through that all in 2 pi. So this is one complete period. So the period on this is 2 pi. And so for the equation, we're trying to fill out y is equal to a sine of bx. So we really need to figure out what is the value of a and what is the value of b. And we need to use that the period is 2 pi divided by b. But this is like a proportion. So that's the same as b is 2 pi divided by the period, algebraically. And so since we know that the period shown here on the graph, this gets me one full period of sine, is 2 pi. B is 1. And that should make sense that B is 1 because there was no change in the period. And so the equation of this, f of x, it's not reflected in the x-axis. We start by going up. And so it'll be a positive 3 and then sine of just 1x because b is 1. There was no change in the period. All right, in part B, it's starting at 0, 0, so therefore it's got to be a sine graph. And it's going up to 1 and down to -1, so the amplitude is just 1. But it gets through one complete cycle. We also can refer to that period as a cycle. It gets through one cycle in 2 pi thirds, so that is the period. So for the equation, my a is going to be 1, but I need to work on what is b. And b is 2 pi divided by the period. And if you take 2 pi and divide by that, you end up multiplying by the reciprocal. The 2 pi's cancel, and we are getting b is 3. So using the exact value, no rounded or approximated with decimals, use the exact value there. And the equation, it needs to be an equation, so make sure you have an f of x equals or you won't get credit for that. And the amplitude is just 1. And it is positive because you start by going up, not by going down. There's no reflection in the x-axis. And then it's going to be the sine of 3x. All right, and then this last one starts down here at -2. Well, it's not starting at 0, 0, so it must be a cosine. And the amplitude is 2 because it goes -2 to 2. However, when I am writing this, because it's a reflected graph of cosine. It's not starting at a positive 2, it's starting at a -2. I'm going to have a -2 cosine of something. So I still fill in this blank. And then the period of this, we end up where we started. We started at -2, went to 0, up to 2, to 0, to down to -2. We end up with one. That is one complete cycle. That is one complete period. And it went for a length of 2 pi. So my b value, again, is 2 pi divided by the period. But since the period is 2 pi, b is just 1. You need to know that because you're going to get ones on your homework where there are more period changes. So you need to have that process down. So in this case, the period was just 2 pi, so it ends up just being f of x equals a -2 cosine x. You have a worksheet for your homework tonight.